All right, so let's talk about it. So there are two different ones. One is an easy one, and one's a more complicated one. The first one you should be able to do sort of on your own because it's fairly straightforward. It's really easy. There's 3 subjects. When you go to bring it in, you're gonna 3 columns, 1 for each of the houses. House 1, house 2, 3, and then a 4th column, the code for the costume. All right, that's it. So you got 1 between groups. I'll just show you. I was like, oh, just go to the harder one. But here, I'll just show you how to set this one up, and you can run it on your own and find the stuff and follow the things. This other one, it's now it's a 3-way mixed ANOVA. So we'll go through that together. All right, so we need then those. That. And of course, don't grab like the descriptives, like the mean situation and sum and all that stuff. I added those so when you do the by hand stuff, it's a little easier. So that's it. There's all like 6 people 3 times. But like I'll just add it here just because it'll match up the other one. I need to code then like 1, 1, 1 is for one group and 2, 2, 2 is the other group. I can clean that up and say, all right, this is costume. I think what 1 is scary and 2 is cute. And here, this is just house 1, house 2. Like that. That's basically how it gets set up. To run it, since you're going to treat it basically like, so with a mixed design, it's a little bit confusing because with the mixed design, there's a between, there's a within. So then when you go to your GLM, and here it's like univariate versus repeated measures because you got between group. Univariate really means between groups, right? Between groups, and then repeated measures. So which way do you go? Is it both? So anytime anything includes anything repeated measures, and if you have 7 variables and only one of them is repeated measures, you still got to go repeated measures to set it up. So repeated measures, the factor is house. There are 3 levels like that. And you can move the 3 houses over. And then costume goes into between subjects. So these are the within subjects variables, and you got a costume which is between, and put that there. And then just follow the rest of whatever it says in the others. Says, include effect size, plot of house by costume, polynomial contrast on house. And then you're gonna again go through and you're gonna find the pieces of the ANOVA and remake the ANOVA table. This time it's the same thing. You're gonna find the repeated measures and the within subjects. You're gonna scroll down a little further to find the between subjects, and in addition to S, like before you always just found S in that one, you're gonna find the S within A, and then the effect for costume. So let's go back to here. Down here is a different one. So this is like the grudge versus the ring. Watching either the lights on or lights off. And then the other C variable is it's a rating of scariness of every 10 minutes. 10 minutes from the room. You can see there's a difference. So all 5 of these subjects saw the grudge at all 6 of those conditions. And all 5 of these subjects saw the ring at all 6 of those conditions. And I'm going to assume that, like, if you're doing this, you would, like, at least reverse order the, like, lights on, lights off stuff. But obviously the time you can't, 10 minutes, 20, 30. But at least, like, half of them saw with lights off first and then lights on, the other half saw lights. I mean, just to counterbalance. But stuff like that's more of a research method, not a stats question. So the way this gets set up, a similar way. Go to a new data set here. I want to grab everything that isn't like a descriptive in this table. So I need all of these. put it here. And I need all these. Okay. So the first 5 are in one group. I'm just adding an extra variable that codes for the groups. And the second 5 are in a different group. So I can go through and start naming these. This is like movie. I use 1 was The Grudge. Shit, I don't remember the order now. Yeah, The Grudge in the ring. Okay. 2 is The Ring. So here's where, when it comes to these, because it's a factorial within factorial repeated measures, the same thing with the factorial repeated measures before, you got to get a little creative with the labeling of the columns, because this is basically the first 3 are lights on, the second 3 are lights off, but then it's also 10, 20, 30, so this is like, I call this like on underscore 10, something like that. On underscore 20, and then on underscore 30, and then the other one's off underscore 10, off underscore 20, and then off underscore 30. I think that's how I have it. It should look like that. So lights on 10, 20, 30, lights off 10, 20, 30, make up those 6, and then the between groups is that way. So it should look like that. I like that if you don't have the codes on. Right? So this is where you gotta be careful about moving stuff over and how you label them. So analyze, generate a model, repeat it again. I now have 2 within subjects, 2 repeated measures factors. So one is whether the lights are on or off. Call that lights, 2 levels. See if I do this right. The other one is sort of time, which is 3 levels. If I did it right, we should be able to move them over nicely. Let's see. So you got to check. So lights 1, 1, 1. Lights on, and then lights 2, 2, 2, lights off, off, off. So just to make sure that they're lined up right. If you have them lined up right, the nice thing is you can highlight all of them and just move them over. If they're not lined up, then you have to sort of one by one move them over in the right order and sort of undo your order into the order that you put it in. Looks like I did it in the right order. Stick movie into between subjects. I'm almost out of time, so the last little bit here is then I put lights 2 levels at a time. I did all that. Move all the within subject variables over. Did that. 2 include effect size, plotted time by lights. All right, so what do I go for effect size? Well, let's do plots first. Looks like it's there. So what did I say? Lights by time by movie. Crap, what the order? Time by lights by movie. So that order usually means to go then the time by lights by movie, like that. So then when I hit add, it goes time by lights by movie. I continue. The last part, effect size and repeated. All right, so effect size is under options, effect size. And then it says for contrast to switch, which one was it? On time. It says no contrast for the 2 variables. That's sort of silly because it won't let you do that. But so for time, I wants to switch from polynomial to repeated. So then the trick for you is to figure out, what does that mean? What does repeated mean instead of a polynomial? And so it used to be that on any one of these, if you just right-clicked on it, a little bubble would pop up and tell you what it was. That was sort of pre-IBM. IBM instead, in every window, stuck this little help button. So you click on the help button, it brings you to a page that might have the information, but it might not. That's the same one I was just on. So dialog, click contrast. Select the factors of contrast, doesn't really tell you anything about what it is contrast types. Let's click on that maybe. You may have to go down a little bit. There you go. Okay, hit a little rabbit hole. So repeated means compares the mean of each level except the last to the mean of the subsequent level. So that takes the level 1 versus level 2. Level 2, level 3, 3 versus 4, 4 versus 5. It does that for all of them except the last one, because you can't do the last one versus the next one because there is no next one. So it's just doing them in order. We're down. So it's not orthogonal. It's gonna essentially double dip at once, because you're going 1 versus 2 and then 2 versus 3 and 3 versus 4, right? All right, so let's remake the, that's why we're here, where all the parts are. So looking back at this, there's, this is this scenario. Nope, I lied. It is this scenario, sorry. This one, you have 1 between and 2 within. Right, so A, this is the movie, and this is like the lights, and then time. Right, so you have 1 between groups and 2 repeated measures effects. So you're gonna have all this mess to deal with. You gotta deal, you're gonna have all these effects to find, plus A, and then all these error terms. So you need to go through and sort of identify what these are. So let's, I'm gonna go to Excel just because it's a little easier to do. So in our source table, we should have all these effects. We have A, S within A, B, B, AB, C, AC, and then BC and ABC. And then for each one of these, this should be B by S within A, C by S within A, and then B by C by S within A. That should be all the ones we have here. And the only thing that's not here is like a sub, well, there's no subject that's S within A. There should be a total. I think that's all of them. So, remembering what these are, it's going to go something like this. The way it's going to work out in SPSS is that you're going to have A is the between groups one, so this is going to be like movie. This is going to be just called error. B, I think, is lights, so this is going to be called lights. This is going to be called movie by lights. And then what they do in SPSS is they just say this is error movie by lights. I think. C then is time. So this is movie by time. So this is going to be error movie by time. And then this is lights by time. This is movie by lights by time. And then this is just called error for movie by lights by time, I think. This is like what SPSS calls these things. So let's see if we can find them. Probably not in that order, but let's see, maybe. I'll put this here, let's just scroll down. So one of the things we didn't do is we didn't actually go through this. When you're going through your output, that first table, the notes or whatever, make sure to delete that, you don't need it. And then we're not doing multivariate, so this whole multivariate table can be stricken from your lab. Do we have any issues with Mockley's test? And then why isn't lights tested? It's only 2 levels, lights on, lights off. So there's no reason to test that. The other ones are fine. And get into our effects. So you have lights. So then should we, since everything is fine here, we can grab the rest of the assumed ones from here. So I can grab like, so for lights, so here, so apparently we did lights first, which makes sense. Lights first, and then lights by movie. Now here I call it movie by lights, but okay, just switch it. It all depends on the order. So it's giving you, it's ordering it by the within first, the between second, which seems a little odd, but that's okay. Just so it looks the same. Lights by movie. I mean, the interaction between lights and movie is the same as for movie by lights, but just to make sure it matches up. And then it says error for lights, which is true. As I call it error for movie by lights, which is true. It really isn't, because it's just the error for lights. Because it's assumed, they call it the error for lights. Even though technically that's the lights by subject within a error term, they just call it error for lights. But that includes lights and lights by movies, the error term for both of those. So this then is here. And so far so good. And then it says time. Then again, I wrote it backwards. Time by movie. And this is going to be, instead of error for movie by time, it's just going to be error for time, because that includes both time and time by movie. So this is error for time. That's this one. Let's grab those. Sometimes you gotta look at this. You gotta like be a little leery of like how to interpret stuff. Because look at the partially to squared in those. 0.981 and 0.958. And that's because the relative to the sum of squares here, the error sum of squares is tiny. So when you actually just add the effect plus 3 point, and we had 178.533 plus 3.533 on the bottom, not divided by a whole lot. So it looks like, you know, the effect is 0.981 when you look at it as a partially squared. But a little on the misleading side. So then lights by time, cool, lights by time. Lights by time by movie. All right. So again, let's order it by the within. And then this is going to be error for lights by time. Notice it doesn't even mention in the error, it doesn't even mention the between groups part. It's like it doesn't even exist. But error by lights by time. That's this one. The only thing missing is I gotta go down to the between subjects, which is this the one that is like the discrepancy between the by hand and the SPSS stuff with the same. See, it just says error, so it's just the error within. So remember when we do this completely repeated measures, there was no movie. It just said intercept an error, and error was the S. Right? The only between subjects part was the S, the sum squares for subject. Well, now those subjects are nested within a movie. That's why it ends up being in the same box. So movie, and so this is technically error for movie, even though they don't label it that way. Let's go here. Oops, I grabbed too many things right here.
Aren't you going to end up with a different total sum squares now, though? If you do it by hand versus SPSS?
Very possible, because these aren't correct. Those numbers will be different. Was both, yeah, they would have to be. Both of these end up being way larger. Yeah, so when you're doing your own total is going to be 3 times these two, right, plus everything else. So just keep that in mind when you go to check it by hand. You have to multiply both these by 3, add everything else in, and you'll get the total that you'll get by hand. They get a different total. I'm not 100% sure why. I just realized that they're averaging over something that we're not. For some reason.
So that's going to change our. Do we have to do ANOVA on that?
No, it's going to do it's all going to be partials. Because anytime you have factorials, you'll be doing partials anyway.
Okay.
It's just these are somewhat ridiculous, the numbers. 98, 95, 89, 90.
You did discover that if you change that repeated contrast back to polynomial, you'll get the same values as you do by hand.
Interesting.
So all of a sudden, that pops back up to.
So the repeated is doing something goofy to the thing. Oh, funny. It shouldn't. It should make no difference whatsoever. It does. All right, so then that's the other thing you do too. Instead of like adding these together, if you want to run it just separately, run it with the polynomials back in there to check your total, see if it's all the same. Yeah, I don't know why doing the repeated would make a difference, because in the background it's doing orthogonal contrast anyway. So I don't know why I would do that.
Yeah.
It's weird. Doesn't make any sense.
So is it going to be right either way? Say the TAs are marking it if I use the 1016 value?
Yeah, I'll make a note that's. Here's the way, if I do this back to here, and rerun it. Still don't want that. Those are still the same. It's down here. Yeah, you get the same number.
Yeah, sort of.
Interesting. So this is the ones you get by hand.
Yes.
That's weird. I wonder if it's because the intercept's also smaller. I don't even know. It should make a difference, the overall ANOVA. What does change? Oh, I think I know what's going on. Because when it's completely between groups, and you run the contrast, it gives you the overall ANOVA up here, like all the effects on it being in one table, right? The between subjects table. Then it gives you an extra table at the bottom that is the sum of all the contrasts. And if it's orthogonal, the sum of the contrast, the sum of squares, will be the same as it is up above in between subjects. When they're not orthogonal, they don't add up. But it doesn't affect the sum of squares in this table, but it does affect the table that comes directly after the contrast, which is not this one. So it's likely they're calculating this between groups from the contrast and not as part of this, which is goofy. It doesn't make a whole lot of sense, but it seems like that's probably what they're doing, or else why would the switching from repeated to polynomial change the sum of squares for movie? You know, it's really odd, but especially since it's not even movie that we're doing the contrast on. We changed it for time. It doesn't make any sense. There's something goofy going on in SPSS that's affecting that, even though the F remains exactly the same and the significance test is the same. It's weird. So just keep in mind that if you're doing it by hand, these are the numbers you should be getting, not the ones that they give you with the repeated contrast in it. So that's true, then these should be the numbers. Well, let's do that. Nope, don't want that. I want this. Is that number? No, I didn't have the. It actually should be the same. I mean, it isn't. Then I'm getting the same partially to square if I do that. Goes this divided by this plus 747. Is that what it was before? Yep. Okay, so it doesn't make a difference that way either. The partially the squares don't mean the same, everything's the same. It's just you need those two numbers to be correct. So you add all this stuff up and get the total. Or else it'll be short, it'll be too small. Something like that. So we're doing it by hand. These are the two sum of squares you should get for movie, and that's subject within movie. And this is the total. Everything else should be the same. So when you do all this stuff, you know, like clean it up a little bit. That's pretty good. Close enough. And then, well, we could make sure that this looks weird. In Excel, this little button, you also can right-click, format cells, and then change the number and change the decimal places here if you want to manually change it. But you can hit this button. This gives you more decimals. This gives you less decimals. You can also convert it to a percentage, but don't do that. It's weird. So once you got that, then paste that in your file someplace, maybe after all this. Any more questions about the output stuff? I'm talking about the by hand stuff. Yeah. Do the formatting. So the repeated, just one last thing before we leave the output. the repeated contrast, so for lights and stuff, we have linear trend, which is sort of goofy because there's only 2 lights. So that's all we got, the linear trend. We just have one light, on, different off. This is going to be the same or some factor of the original linear. What you get is what we were talking about before. So let's say for lights there were more levels, and it's doing a linear trend for lights. And then it's actually is an interaction between the linear trend of lights and between the 2. So we're talking about there, if lights have more levels, it's asking is the first and last levels different in a way that it's different across the different levels of movie. So that interaction, there's only 2 movies, only 2 levels of lights. If there's an interaction between lights and movie, it's already been done. You don't need to further break down, right? Because you don't need to do a linear trend with only 2 groups. So if you look up, I don't off the top of my head remember, but up here, lights by movie is not significant, right? So coming down here, I don't care about any like this, right? Because I shouldn't even be looking at it because it wasn't significant. First place, so I don't care about further breaking it down, even though there is no further breaking down here. It's 2 by 2 interaction. That's it. I'm only mentioning it because, like when we talked about before, this is where in your output you would look for a linear by movie trend if there were more than the 2 levels for each one of those. It would do the interaction between linear trend of lights by movie in this box, which I think we've seen before in previous, like in the all repeated measures, those things sort of existed. Doing those are interaction contrasts. It's showing the interaction contrast between some trend and the other variable of some sort, trying to break down the interaction somewhat.
What do we only get for time, level 1 versus 2 and 2 versus 3 and not 1 versus 3? Is it degrees of freedom?
Because we chose repeated.
Okay.
And repeated always goes like whatever starts with the leftmost level.
Okay.
Or the numerically the first level, because this is repeated, so it's leftmost. And then takes that one versus the next one.
Okay.
And then does the next one versus the next one. So there's only 3 levels. And then 2 degrees of freedom, so there's only 2 tests. So it's doing 1 versus 2, 2 versus 3, and that's it. There's no more degrees of freedom. Okay. It does all of them except the last one, because the last one doesn't have one comparative. That's just that I picked repeated for no reason except that you didn't know what it was, and you had to figure it out. Or we had to talk about it, but how to go through and figure out what the contrast is doing. There's all these different ones that are the ones we didn't talk about. So if you had picked a deviation, because the mean of each level, instead of a reference category, it's the mean of all of the levels grand mean. The levels of the factor can be in any order. Each level. So it's basically, it's asking, is each group different than all the other groups combined? Simple compares the mean of each level to the mean of a specified level. This type of contrast is useful when there is a control group. So you can either pick, you have to order it so that your control group is either the first group or the last one. And then you decide, when you go to input it, it's one of the only ones that asks you what's the reference category. So I go here, here we go, repeated measures. If I go in the contrast and switch it for time to say simple, you notice when it says polynomial, this last first thing is grayed out. But if I switch it to simple, it comes back on. You can tell it which one of those is your reference category. So if you have it on last, so every last category does the first one versus the last one, second versus the last one, third one versus the last one, all of them versus the same one. If you pick first, it's the second one versus the first, third versus first, fourth versus first, all of them. So if you have a control group, this works because this takes every single group versus the one control group. That's what the simple contrast does. There's Helmholtz. and difference. So let's see what we didn't talk about. Helmholtz compares the mean of each level of the factor, except the last, to the mean of subsequent levels. So the mean of each level of the factor. So instead of doing 1 versus 2, it's going to go 1 versus 2 and 3. And it's going to go 2 versus 3. So if I had 5, it would have been 1 versus 2, 3, 4, 5 combined. Then 2 versus 3, 4, 5. And then 3 versus 4 and 5. And 4 versus 5. Make sense? It's taking each group versus the mean of the subsequent groups. That's Helmholtz. Difference. So difference is apparently reverse Helmholtz. Compares the mean of each level except the first to the mean of previous levels. Right, so it's going to skip 1, it's going to go 2 versus 1. 3 versus 1 and 2. 4 versus 1, 2, and 3. 5 versus 1, 2, 3 more. It's going to do each group versus all the other groups before it combined. Now, whether or not you find these actually useful ever, that's a whole other story. But these are like set up, SPS has to use them, but when you would use them, it would depend on your design. The simple makes sense. If you have a control group, right, you want to compare everything to the control group, that makes sense. That's a useful one. I can see that. Like, they're not going to be orthogonal, that kind of stuff, but maybe it doesn't matter. I don't care. I just want to compare everything to the control group. But the default always is going to be a polynomial, just because it's orthogonal and stuff. But there's other uses, other types of contrast you can use. And of course, you can always put in the special. You have to go into syntax and write special, and you can write your own contrast however you want. Compare whichever you want to compare if it differs from these built-in contrasts. But the idea was if I asked you to do a thing like use repeated, and of course you're going, well, what the hell is repeated? Well, click on help, and that tells you that's where to go to find out what repeated does. It used to be you literally right click on symbol, a little bubble will come up and it would tell you the information. Now you have to hit help, and then help takes you to not the right page, but a page sort of in the vicinity of the right page. And you got to go down and click on this contrast types to then get you to what the actual contrasts are and use an explanation. And even this, you may, after reading it, not be that clear what that was doing. There's certain stuff that are very short, which is nice, but sometimes it's not enough information to really give you what you want. All right, other questions about the output? Because it's a three-way, oftentimes the way it gets split up is that it's taking two ways. This is a time by lights for the grudge, and this is time by lights for the ring. So it took the interaction and split it up in two different graphs, and split the graphs by the movie, and showed the interaction between time and lights for each movie stuff. You could choose it differently. You could have it so that the two graphs are split by lights, and you get the interaction between movie and time. Right? Depending on what you wanted to look at, how you wanted to break it down. There's different ways you could have done that. I just chose time by lights by movie, so the movie is the one splitting up the graph. Because when you go into here, you may not even notice when you do it, but in the plots, first thing says horizontal axis, then it says separate lines, and then it says separate plots. So we did time by lights by movie. So movie is the one separating the plots. All right, let's talk about the tougher stuff down here. So the first thing about I'm assuming no one's doing deviation approach. I'm not like going to kid myself and thinking you guys are going to do like all the deviations, but even for computational approach, you have to go through and redo some stuff. So if I took this, and I already sort of did it, but I can show you how I did it. You'd want to go through and grab the table up here. Easiest way would be like to stick it into Excel somehow. Again, which I already did, but let me show you how I set it up. So here's the whole thing. I'm doing this based on the sort of the computational approach, I don't really need the means or the standard deviations. I don't really need the sums. So I don't need the case means either. All right, so let me back this up a little bit so you can see. So there's the whole, this is like I just took the data, the whole data set that had everything in it, right down to just the sums, so the scores and the sums for each cell, the sums for each A level. The only thing I don't have, right, is I don't have the sums for the C's alone, I don't have the sums for the B's alone. So I got to remake the data. So in this format, if I was doing this by hand, in this format, what's, let's do some up. Like write that online, because I got rid of other stuff. So I got to move this one back up again. And then this one on that here too. Also, I'm like, wait, the subjects don't line up anymore. There we go. And this doesn't line up now either. Don't need a grand mean, technically either. Right? That's better. Okay. Also, it bugged me that the subject's totals weren't lining up with the subject line. And I should, 6 through 10 lines up to 6 through 10. We really should have been weird. So, in this format, I can figure out as an A. I can figure out the effects of A. And I can figure out the B, well, I can figure out the A, B, C interaction and the B by C by S with an A error term. I can figure all those in this format, right? But I can't get the effect for B, it's not easily. I can't get the effects for C or the BC, not going to BC interaction. I can't do B or B by S with an A. I can't do C or C by S with an A. So I need to reformulate everything so that I can do that. So I want to do this for, say, for B first. These are, since they're going to be the same, I can just copy these. What I need is to collapse everything. So like, it's going to equal the sum. If I want all the B's, so I need subject 1, their B1 total is there. Right? Their B1 total is like the first line. So if most of you guys already do this, I feel like if I'm walking through this and you guys already did it, I don't need to do it. I need some help. Anybody need me to walk through this stuff? Raise your hand if you want me to continue going through this stuff. Like, okay. Because I just feel like I just all of a sudden you get this weird, like there's like a vibe you pick up on, like we're just like, I'm bored, you know what I mean? Like this is there's I just feel like can we get to something more interesting vibe going on? I'll do it. How about just go fast? So we sum those up. Did it for every person. I can play around a little bit so that I can get all of them in there. Yeah, that worked. I can technically just pull this down because it's going to be the same. If I'm summing the sums, it's going to be the same number. But if you want to check it, you can do a sum This equals the sum of these. So it's the same, copy that, the sum of that too. So then this is essentially B1. So I need B2 as well. If I pull this to the right, it won't work. It's not correctly, because it'll be those instead. It'll be off. I need the everything on B2. But if I do it for the first one and then just adjust it like that, I can then drag that down for the rest of it. It should work out fine. Copy the sums over, so it's all good. Another way to check too is if I sum it this way, I should get the same numbers that I have here. So 106, 192, 78, 92, and 468 is the sum for A1. This is just a way of sort of checking. Hold on one second. I told someone that I got a key from you. So looks like everything's good. This is the setup for B and B by S with an A. Then I do the same thing for C. I do it a couple different ways because I don't want to be going back and forth like this. I could. This is going to be for C. I could take the view and say maybe I'll split it. Don't need to split it this way. Just need to split it that way. So now I can do same thing. I'm going to grab these. Are going to be the same for the most part. So now I need the sum C1 and C1. Right? And that should be able to be there. Make the sum. So now I should be able to, because these are adjacent, I should be able to drag these over twice and have the whole thing. So check it. That looks right. That looks right. That's the sum of those. And here. That looks right. Okay. So then here's my C1, 2, 3. And again, the check, I always add up. Just add up the score it this way to make sure I get the same subject sums. It should be the same no matter what. No. So the effects up here, right, I can, in this format, I should get rid of this. In this format up here, I can get the, I can get A. Crap. A, S within A, and the B by C by S within A can all be done in this format up here. Down here, I can get B by S within A. Oh wait, I can also get B by, I get BC here too. Right. So here's B, S with A. Down here, then is C, and C by S with A. Miss anything? This should be B and AB. So where do I get? Oh, that's true. So this is going to be B, AB, and B by S with an A. This is going to be C, AC, and C by S with an A. And up here is going to be A, S with an A, BC. It should be BC, ABC. I forgot that one. It's BC. A, B, C, and B by C by S with an A. Somehow, get all that stuff. Why is this thing stuck? Okay. I lost ABC. ABC. So look at weird. Okay. Is everybody clear? So once you sort of figure this out, where to go from there? Because we have all those effects. Got to break down. We need all of these broken down into degrees of freedom, so we can actually break these. That. It's all fun. Doesn't matter who's the only one. So. I should probably actually do it here so it gets recorded. I'll do it this way. Okay, so we're doing it. this way. A is the easy one, should be anyway. So for A, sum of A minus 1, so that is the sum of AJ squared over B, C, and S minus T squared over A, B, C, S. Right? So those of you who already did this, you like it. This is it's supposed to go. So S within A, it's going to be A on the outside, S minus 1, so that's A, S minus A equals the sum of A, J, S, I squared over B, C, S. Remembering that we have A, B, C, and S are our letters, minus then the same sum of A, J squared over B. Nope, I screwed that up. This is just over BC, no S on the bottom. This one's got BCS on the bottom. B is just B minus 1, so that's sum BJ squared over ACS minus the T squared over ABCS. A B is A minus 1, B minus 1, which means it's A minus B plus 1. So that's sum of, what the hell is happening? Trying to fix it, making it worse. A, J, B, K over, squared, over, it's going to be C, S, CS, minus the sum of AJ squared over BCS minus the sum of, BK squared over ACS plus the T squared over ABCS. Right? So far so good? Having fun?
Yeah.
I know I'm having fun. You guys have to be having fun. C minus 1 equals sum of C, I don't know, CL squared over ABS, right? Yeah. Minus T squared over ABCS. Then we're going to have AC equals A minus 1, C minus 1. Looks just like this, but with C instead of B. C and the B switched. So sum of AJCL. L. I think L is a bad one for this. The N's for, or M. Yeah, let's do something else. So CL, let's use M, I guess. For Christ's sake, yeah. Squared over then BS minus sum of AJ squared over, come on, damn it, right? BCS minus Sum of the sum of CM squared over ABS plus T squared over ABCS. What's left? Is it B, AB, C, AC, BC, correct, right? And then we need ABC. That's the fun one. So that's then B minus 1, C minus 1. Stop doing that, damn it. Sum of BKCM squared over AS minus sum of BK squared over ACS minus the sum of CM squared over ABS plus T squared over AB. This looks daunting, but at this point, like 90% of it we've already figured out. I mean, like, it just repeats. As you're adding each new one longer, all but one part of it will be a known value. It just make sure that you solve them as you go. Don't wait to the end and solve them all at once.
That takes a long time.
Yeah, don't get me wrong. It's not like it takes no time, but you shouldn't be like recomputing these every single time. You've already got them. Just compute them the first time and keep carrying them over. So it looks like way more than it really is. We haven't even got to the other errors yet, by the way. So these are all just the effects. So then we got I'll have to do the other one next page. We're at it. Almost out of time. Okay. Can I? Another one. Blank. So A, B, C. It's fun times. So this is then A minus 1, B minus 1 times C, C minus 1. So I just have another, that's going to be A, B, C minus A, B minus A, C. Come on, right? Minus BC plus A plus B plus C. I just want to write sometimes. C minus 1. So that's the sum of A, J, B, K, C, M over S minus sum, yeah, of course, squared, yes. A, J, B, K squared over CS minus the sum of A, J, CM squared over BS minus the sum of BKCM squared over AS plus the sum of AJ squared over BCS plus the sum of BK squared over ACS plus sum CM squared over ABS minus T squared over ABCS. So those are all the effects. We did one error. So we're missing these three errors. Right? So we're out of time, but I'll do one. So we're doing like, I'll do the worst one, yeah? The massive one on the bottom. Okay? So B by C by S with an A. So again, whenever you see the B by C by S, and you get this within the A thing, bring the A outside. Bring the A outside, and then you're going to have B minus 1 times C minus 1 times S minus 1. So we distribute all that out, it ends up being BCS minus BC minus BS minus CS plus B plus C plus S minus 1. So now you're going to multiply the A through there, so it ends up being ABCS minus ABC minus ABS minus ACS minus AB plus AB plus AC plus AS minus A. The good news is that ABCS finally is the sum of y squared. Yay! Okay. Then you got minus the sum of A, J, B, K, C, M squared over S minus the sum of A, J, B, K, S, I squared over C minus the sum of A, J, C, M, S, I squared over B. So those three plus the sum of A, J, B, K squared over CS plus sum of the sum, yeah, sorry. Sum, like fighting with the screen at the same time. ACAJCM squared over BS plus AS, the last one, I think, last of the twos anyway. Sum of, actually I can do it that way, it's not enough space. Do it here. Sum of AJSI squared over BC, right? Minus the sum of AJ squared over BCS. So it'd be all that craziness. That's the only one that's going to have the ABCS. These two are roughly the same. You're just switching the B and the C. They get, far from each other, but it distributes out the same way. It's going to be the BS minus B minus S plus 1, and you multiply it through there, so it ends up being ABS minus AB minus AS plus A. You just plug all those in. This is going to be ACS minus AC minus AS plus A. And you plug all those in. It's a lot of stuff.